have another chance to look at it in a little bit when we get up there. Let's come wide.
That's that sponge we just imaged a minute ago.
I'm just doing a little zigzagging while the train gets rolling here. I should say the bus, the tour bus for science.
Science train? Is there something wrong with a science train?
Well, it's more of a tour. Well, actually, train, yes. We are linked together, and so
we're all from different cars, maybe? Just the partnership thing? Just
there you go.
I'm in caboose back here. This is going nowhere, isn't it? So this sometimes you start in on a line of stupid jokes, and it just, you can tell already you're going to wind up in a black hole. So
maybe I can dig us out. Maybe we should train our thoughts in another direction.
I think we've derailed the conversation.
Yeah, I knew the rail joke was coming in. I knew it was coming in. Figured Roland brings it up, yeah.
This is what happens when there's not enough biology to keep you interested.
You took the words right out of my mouth.
We need some geological commentary here, and it's Sunday and everybody's at the park or soccer with kids.
We get to see these glorious views and show them to those sitting at home.
Well, it is a pretty spectacular terrain. It's not like it's a flat mud bottom or something. There's a lot of topography here.
Right.
Yeah. Good for it. To sedimentologists out there, nothing against mud bottoms.
We'd have less against it if they call and describe it to us.
On Sundays, the geologists are out with their picks, and they're up on the hills, I think, picking out rocks. Probably not. I'm kind of enjoying my Sunday here, just looking at a bizarre new seamount that has never been explored before. That's a pretty great way to spend your Sunday. This is called Wetmore. It's, I don't know, it looks just as wet as some of the other seamounts we've been to. But it's potentially called Wetmore, and I am not going to tell you the origin of that name because I'm going to lure Dr. John Smith onto the phone probably tomorrow to describe some of the proposed names that he has submitted for these seamounts.
What are the two white things in the image? Just sediment?
Yeah, it's just channel sand. This looks very young, and it looks like it broke up older lavas or basalts because it's angular, and then you see pillows, so something looks like it pushed out.
It did look like it sort of split open, doesn't it, Pilot? Right there.
And if we engage in enough speculative geology, pretty soon somebody back home will jump out of their chair and get on the phone to set us straight.
I get your plan, and I like to do that too. Let's see. Okay, so Les is saying that the regional oceanography suggests that the prevailing current direction should be east to west. Yep, I'm aware of that. And maybe when we get to the top of this feature, we can find out if that is true or went off bottom. Yeah. So right now, Les, we're kind of in a current lull, so I'm hoping that it'll pick up a little bit. But we haven't seen much of anything at all here today. So I'm a little bit, I find that a little bit curious, given that we are on a sharp ridge where we should get probably more current flow, or at least I was expecting more.
I would expect it to be just ripping across here, but it's not.
It's not. Yeah, it's just curious.
So the question is, what's to the east of us on the tens to hundreds of miles scale?
Not a whole lot. We're kind of in one of our southernmost seamounts. There are some other seamounts here, but they're all spaced out a bit. We are on sort of the southwestern side of a fairly large seamount.
Coming down. It just went away.
You know, pilot, we have been at the same depth for like quite a while. It's as though we're in a little bit of a flat area along this riff.
Well, I see.
And I wonder if that's maybe why we're not getting that much current, is that, as I recall, there's a little bit of a saddle part on this ridge that maybe that's where we're in. And then
ROV nav bridge, move complete.
Let's just get another one going here, because it's we're starting to make bad jokes. We need to find some action here. We are definitely on the local spine.
Yeah.
And my heading is 045, lined up with it.
Yeah.
So you think I should move to 050, 045? Or should I stay at 060?
I think our next move should be
It's
045. I think.
rotating
Copy
between the port quarter, stern, and starboard quarter.
Copy that. So right now, is it? Would you say it's more towards starboard or more towards port?
It's more toward starboard, almost angling to starboard abeam.
Copy that. Thank you. We're just taking notes down here because we're checking. We're checking on a couple of our instruments.
Right. It's now port quarter.
Copy that. Thank you.
Okay.
Yeah, that thing spins around pretty quick.
Navigator. Next move, let's make it at 045. I'm gonna turn right now, line up with 045 with the pilot, and copy that.
Got another Bolosoma sponge off to the left.
Yeah, we don't need to wait for the swing to come out. We just keep it moving. Okay.
Copy. I'll keep my eyes on
A
sonar.
lot of
I don't see anything though.
lavas
We're now
here you're
local
seeing
high.
on the floor. These are very old, eruptive.
Hey,
Copy.
Got it, I
Dave,
got it.
got it.
Yeah.
So
The
we've
front
got
end
a
is to
nice
the left.
sea cucumber in view, and more than that, we've got a nice feeding trace that is left behind on the rock.
Come on down.
This is the bridge. Go ahead.
We are ready for another ship move.
All right. Go ahead.
30 meters, bearing 045, speed 0.2 knots.
You're getting pulled quite a bit. Come down a
That's
lot.
range 30 meters, bearing 045, speed 0.2.
Good copy.
Coming up.
down.
There's another clear one on the bottom.
Oh, I see that.
I don't think I can come.
Sure you can.
I mean, I'm 10 altitude right now.
That's all right.
Come down much more.
Does look like you're on a bit of a high there.
So as we're drawing closer,
It's all right.
you can notice that there's the rock itself is covered with a white band of sediment and probably
ROV nav
organic
bridge,
material that's been
moving
deposited as the water falls upon the surface. So this sea cucumber, whose mouth appears to be on this red side, is sort of making its way around in what appears to be a spiral pattern. It's got the feeding tentacles. It looks like the mouth is reared up. And what they're doing is they're ingesting organic particles that are probably mixed in with the sediment and digesting them. You can see very clearly where the food is going because the body's translucent and the sediment is something you can view right through the body wall. That's its intestine right there. And what's great about it is you can literally see sort of the beginning to end. The only thing it needs to do now is leave sort of poop or castings. but you have the spiral trace in the sediment, the sort of Lebensburen, the track. You even got a little bit of the mouth action going on the left, right around that really dark red area. You can see some of those. They're slowly sort of putting sediment into the mouth on the left side in the upper corner, and at some point it will probably move on or leave a little bit of clean sediment behind it after it's absorbed all of the organics. But other sea cucumbers actually can change the microbial composition of a lot of the sediment, and so these become important for the ecology of these areas. Some of these can swim, so sometimes I live in hope that we're going to see one just take off, but I think this one's just kind of curious.
we can
No, it's all right.
suggest to it to take off.
We can move on.
Can,
Thank you.
Come wide, please. If I give
And
a
just
little
get a good shot of the track is all good. Thanks.
a little bit of prop wash might make him leave.
Oh, I wouldn't want to be interrupted when I'm eating. That's all right.
Okay. All right, wide, please, Ron.
Beautiful white.
Oh,
You can also see a potential snail trail or something, a black line.
yeah, I need to come back up this terrain, and Fernando, you can come back up, and
Okay.
you'll feel better
Yeah.
heading over this away.
Yeah.
See
What's
an
that
enemy?
over on the right? It's yellow, but it doesn't look like a bull
Orange,
somewhere.
yellow.
You're talking about
An
that
enemy.
ball on the boulder?
Yeah,
there?
the ball on the boulder. Do you see
Bottom
it,
right.
Dave?
Yeah, it's gone off the right corner, the lower corner right now.
Stand by a minute, and I'll have a look at it. Just come over
Could
this
be a
way.
dead sponge, but
No,
I'm
I
not
think
so
it's a
sure.
big
I
sea
see it.
anemone.
Yeah, I think
Yeah,
you're right.
okay.
It's a big sea anemone, is right.
We can approach.
Different translucent, taller 3 and lower left of that.
Yes. Okay. We'll try for both.
It's a good angle on the anemone.
So sea anemones are one of these animals that is notoriously difficult to identify from video. If you think it's hard to do sea stars and corals and sponges from video, then you haven't seen anything yet. These anemones, most of the time, their taxonomy is based on doing a dissection and looking at their internal structures, specifically their mesenteries, in the arrangement of the mesenteries inside, which we can't possibly see. So we kind of guess, and then sometimes can get the family on
Up and
these
right.
things. I think this could be in the family Actinostolidae, be a best guess. That's kind of a catch-all right now for a lot of these big anemones we see down there.
The lasers would suggest that the base on this thing is 10 to 15 centimeters across at least, so it's a good-sized creature. So sea anemones are usually predatory. All of these tentacles are essentially filled with stinging cells, and so in other situations I would expect them to be feeding on something like fish. But this one, given how few fish we've actually seen,
ROV nav,
I don't know,
move
maybe
completed.
the worms or maybe certain crustaceans, but they would sting them with these tentacles and then move them right into the mouth there.
Copy.
There is, by the way, sea anemones, basically, like a lot of other cnidarians, they don't have an anus. It's just the mouth opens up into what's called the gastrovascular cavity, and so the food goes in the mouth, it's digested, and then just comes out the same hole. So they're neat animals. We can pull out when you're ready.
Video's
Yeah.
clear.
Okay, wide, Ron.
So we're getting some help on these anemones from Nadia Samarian, and she's an anemone expert who is, I'm for the life of me, I've got to remember what her institution is, but she's in Kamchatka right now, and we also get some help from Michelle Rodriguez. And we got a little distracted. There's a sea anemone or sea cucumber down there, as well as a small bolosoma sponge, it looks like.
Either one looks fine to me.
Okay to zoom, Roland.
Another synelectid, huh, Chris?
Yeah. Well, this one's different from the one we just looked at, by my reckoning.
Maybe, yeah. 4-0
But
would
same
be better
family though,
since
right?
she's on that side and
I think so, yeah.
the slope seems to be going up that way.
Well, you can see the feeding tentacles sort of scraping along the bottom, or it's not scraping, just sort of absorbing food along the bottom. And again, a nice
Video's
transparent
clear.
gut.
Okay, go
We
to
can move on.
bolosoma. Oh, there it is over there to the left.
Yeah, we've got
We've
this already.
got
It's just a small,
Gazillion of them.
yeah, gazillion of them. Little bolosomas. These are the little
Or
glass
even if you want to
sponge
make
that
it
were-
0.35.
White
Is
thing
that a fish or a
straight
trout?
ahead is different.
Some kind of,
Looking.
are you talking about that white?
Yeah, it's on the rock.
Yeah.
Let's see what he sees right here.
I think it's
Okay.
just the
We can
dead
snap?
stock. Yeah, snap. That looks dead sponge.
Yeah, dead sponge stock.
Okay, wide, please.
Got branches.
Couple
Hey,
of crinoids
that
on it.
rock has all these trails on it.
Trails.
Barnacle,
Yeah,
white
notice all of
strips.
the patterns that are on the surface of it. Are those stoloniferous octocorals or
Let's,
possibly
have a look.
tunicates?
I think they could be stylasterids.
Oh,
Moving
really?
Yeah, the ones that are sticking up a little bit.
Yeah. Oh, that's
But that's a
interesting.
guess. I'm just trying to see if I can get
okay.
an eye for them.
Yeah, you see how
These
they're
could be barnacles also, the
Barnacles, yeah.
smaller ones.
yeah, they're forming interesting patterns on the surface.
And I'm not seeing anything sticking up right now.
Okay,
I thought I was,
go
so I'll
for
bet
zoom.
these are all barnacles. Dead barnacles even. Yeah,
Are they?
yeah,
Yeah, they are.
dead barnacles.
So this was a good place to be some time ago, and now it's not. I wonder. You know, there's no current here now. Maybe there was, once upon a time.
There could have been, but the other thing that concerns me,
Good shot
Pilot,
right there.
is the fact that usually in pretty good communities we see a lot of dead members on the seafloor because there's multiple generations that have lived there. And we have seen a couple of dead things this morning, but not a whole lot. So I'm a little concerned. I'm concerned in that we're probably going to see this for the rest of the dive, but I'm also kind of happy that this is supporting the 2,500 meter
Clear.
possible boundary, if there is a boundary. But then you never know, because this area just might not get a whole lot of current flow, and that's all that's going on, even though it's a great ridge. Who knows? All we can do is continue to explore, continue to get more information, and eventually we'll understand it a little better.
Well, it looks like we've come up on another little hummock here, and we'll have to descend to continue on this course.
It's the part that kind of surprises us. The multi-beam bathymetry, the data we look at to pick sites, it's usually gridded at 20 meter resolution maximum at these depths, and it just doesn't pick up these little lumps and ups and downs. So we don't see this. Sometimes we're surprised seeing a lot of these ups and downs and little flow features and cones. And I think that's what's going on here. It's just a lot of smaller topography that all kind of got smoothed
Well,
in our maps.
Yes, we are.
Yeah. So I'm going to
Well,
line
that
up
was a
with
little burst
0.0
of
pilot.
Okay.
diversity. So I think, in a purely naive, optimistic sense, that things will
Bridge,
pick
go
up.
ahead.
Ready for ship move, please.
I live
All
for
right.
hope.
There you go. That's more
Yeah.
comfortable.
We'll
We're looking
see
at 30 meters.
many,
at
many more things.
040 degrees, 0.2 knots.
Well, I would love to be
30 meters, bearing, 040.
proved wrong.
Line
I
up,
imagine
040
everybody
decimal
else
two.
that's
Good copy.
Coming up.
looking at this possible boundary would love to be proved wrong as well. I'd just love to see great communities at any depth, frankly.
So you can come down to about 10 meters altitude there, Fernando.
Copy.
And you're still up on the top there.
Yep.
But you'll catch up shortly.
ROV nav.
I'm
Move
somebody
initiated.
who believes in the law of negativity, that the more negatively at least you express yourself, then the more positive things happen. But I'm going to throw this out. We're going to do another ridge tomorrow, and I'll bet it's better.
Let's be careful with the tether right there.
I'm just saying, I
sorry.
think it's better. It's a different orientation. It's going to get there's a possibility that the prevailing current flow is a little more northerly
Yeah, there
here.
you go.
And
I
if that's
have
the
it on
case,
camera.
we're on the backside of the guyot.
But
I
it's
gotta
And that's
come
not
up. Yeah, we
great.
gotta
Little
come
bit,
up.
This
yeah.
other one is on the eastern, southeast end of the guyot, and it may be clear enough from it where we're going to get better current flow, and we might
Yeah, now we're
might get a really good
There you
ridge.
go. Yeah.
And
that's
that would be
much
nice
better.
to see.
Well, following your rule of reverse negativity, I bet it'll be terrible.
Thank you. So if I was too positive there, I'm glad you
We're
neutralized
not
my
going to see
positivity.
any sponges at all.
But don't give up on ridges, all of you out there. They're good. And Scott says, careful with that hypothesis testing, buddy. Yeah, I know. It's speculation. All we're doing is exploring and accumulating more data. And at some point in the future, we'll have enough to really say something conclusively. Right now, we don't. But that's the process. That's the process that all researchers are engaged in.
So, pardon the murk. When we go downhill, we have to adjust our clearance over the terrain so we're not basically dragging our leash around the shrubbery, to use the dog walking analogy.
So, Pilot, could the general public hear you with that? I'm just making sure that they copied you on that, or do I need to repeat it?
You could repeat it for the people listening on to Science Only.
Oh, okay.
I'm in the right channel. ROV pilots appear on the right channel of the stereo, and you appear on the left, and they can turn the knob depending on their interest.
Okay, well, I was just going to let
There you go,
everybody
Pilot.
know
If you
why
want,
we're
you can
so
push
high
out a little
here.
bit, maybe
With all of these
calm
ups
down.
and downs, when we go over a little topographic high, which
25
apparently are
altitude,
abundant
so I
on
can come
this
down a little bit.
ridge, then the ROV's got to get far enough along and out far enough to clear its backside from this topographic high before it can get down again. And so that's what's going on. This is not just a straight shot ridge. This is mound by depression by mound by depression, and it's been going on all day. But anyway, if you're noticing this and wondering why we're periodically getting so high up in the water, that's it. And Scott just concurred that he can hear you on the video stream. I think he's at home, so he's listening to the public feed.
Okay, I'm following you down as I can.
Yeah, that's enough, because I went over the corner here just to have something to look at
Copy.
while we head this way.
Yeah,
Alright.
so a point that Scott's made here in the event lot, Scott France from the University of Louisiana Lafayette, is that we are exploring. we're exploring in as scientific a way as we absolutely can to get as much value out of the explorations. But what we're really doing here is we're hopefully coming up with enough observations where people could start to potentially come up with hypotheses. But we're not testing these hypotheses right now. And that's, I may have misled some people thinking that we're accumulating, we've got a couple of hypotheses out there regarding a possible boundary for these high-density communities. But what we're doing is just accumulating data, and, at some point then, if we've got enough data and we've got some reasonably solid hypotheses, then we're hoping that there'll be follow-on work to rigorously
we're
test these
still moving.
hypotheses.
I feel the swing right now.
And determine their value. So that's the process.
ROV nav bridge, move completed.
Copy, Rick.
We're ready for another one right now. I don't like where we're at. No, just continue on the same heading. I'm looking off in another direction here to keep my tether off the rocks.
It's the bridge, go ahead.
Let's go ahead and do the same move. 30 meters, 040, 0.2 knots.
All right, repeating move, 30 meters.
So if you've been following with us since this morning, you know that we've collected several specimens, and these will be brought up and studied by researchers. Material from the biological side will be so the corals and the sea stars will be deposited at my home institution at the Smithsonian's National Museum of Natural History,
Pilot, if you want to
where
move
they're
forward
generally made available
sponge
to
or
the scientific
anything
community.
else, you can go ahead.
The rock specimens, I believe, are sent to Texas?
No, to Oregon State
To
University.
Oregon State University.
To Dr. Anthony Copper's laboratory. He's got a repository set up at OSU. And we've got a really nice arrangement going with
ROV
him.
nav, move initiated.
And he's doing some preliminary analysis on the rocks as well, and providing these to researchers via his website.
And specimens that are collected and that have been collected by Okeanos, as they are available at the Natural History Museum, are generally requested by researchers which are at other institutions for loan, so that they can study the material within the context of their own lab. And so there are scientists who will often be able to compare the material collected, so some coral, for example, and compare them both against other specimens in terms of their appearance and also their molecular with molecular data to sort of look at their relationships. And this gives scientists called taxonomists data in order to distinguish a new species and then to describe that. And so there will probably be periods right after these big Okeanos expeditions where there will be a lot of publications following, which are often translated into for more popular articles so that people can follow up with what's happening.
Roger that.
Many of you may remember from several expeditions ago that we saw, for example, several attempts to collect a small white sea star that I kind of coined a cookie star, or in the family Goniasteridae. So, for example, that specimen has made its way to the museum, and I had a chance to examine it before I took off for this expedition. And it turns out that that sea star is a new genus and species, and so that will be published at some point as I get all of my ducks in a row and get that paper ready for publication.
Repeat.
Come in just a little bit. Get that.
So Roland, if you're going to look at some more of these yellow sponges, then you have to do a highlights video, because I already got your title already, and Annie's in here now too, as well as Tara. Now you guys think of this title: giant yellow lollipops. Huh? And he's doing some really nice circular videography, and I could
Lasers
talk
are
about
clear.
these things. And the first time I saw them,
Lasers
I
off.
mean, they're shaking their heads yes. I don't know if that's like just bobbing no up and down, or is that actually saying yes, you might consider it. Who is? You could relay that to her. I could capture her. I mean, come on, is that a great title or what? And we got some great imagery of these things. Although it looks like somebody took a bite out of my lollipop here, which is a little rude. 'Cause you're not supposed to bite them, right? You're supposed to suck on them for a while so they last.
Yeah.
But
I see that.
How many bites does it take to get to the center of your sponge?
well, I don't know. It might take some. I'm not sure there's a Tootsie Roll in the center of it, but... Hey, Roland, you'd agree, wouldn't you? That would be a great highlights.
Maybe if I didn't see that dandelion pulsing.
Oh, jeez. My sponges get no respect whatsoever. Okay, fine. I'll do my own highlights. Okay, we call that sponge that we just imaged Bolosoma. It's kind of an interesting name. Bolo, I think, being round or ball-like, and soma, body. And so it's got this big round sort of body on a stalk. That's our best guess as the origin of the name.
I think we were in Indonesia when we saw one that was almost a meter across.
Yeah, and that pilot, they probably didn't make a highlights reel then either, did it?
Oh, I think it.
It absolutely did.
Did it?
Yeah, and I think Roland was sitting in the chair, directing me as he often does. And, it's in the can somewhere.
Okay, I'm going to look for it.
I've had many good chauffeurs along my rides.
What are these interesting things?
Sediment channels?
Geological structures.
Pillows?
Huh. Oh, okay. I thought they were depressions. They're rocks. My mistake.
Yeah, we've come down off a pretty big ridge,
Large whip to the right,
protuberance of
straight ahead.
lava there. Yeah, there's some stuff out there.
Chris, is it not true that these types of whip corals ahead are the ones that do the, what is it, create their own light when they're touched?
I don't know. I mean, I'm certainly would be up for this little experiment if you wanted to give it a go, but I don't know if Dave's willing to turn off the lights.
Complete.
So our videographer, Roland Bryan, he just pointed out that these corals do light up when they're touched. They've got some...
May light up. I'm
Well,
a video
no,
guy.
I'll bet they do. But anyway, if you've never seen it, it's pretty amazing. We used to do this sometimes on the very tail end of Hurl submersible transects and dives, where we had a little bit of time left, so we went and we kind of teased some bamboo corals, I have to admit, to light up. But I mean, if that's a...
Another coral in the bottom, between the crack.
Oh, yeah. Sue?
Okay. It's another Pleurogorgia. They're around, but they're not in high abundance. This is a Chrysogorgid. And it's looking somewhat like Pleurogorgia militaris. It's not perfectly clear
There's
that's
some
what it is.
anemones on it.
And we think that the reason it has the name militaris is because all of the polyps are lined up sort of like military formation along the branches. So we've seen this coral a couple times already this morning, and we've imaged it a couple times, so we're fine when video is. But
Video's clear.
What?
High note on the base of the whip.
We're now in an area of sheet flows or something. I guess that would be my interpretation of what we're looking at. Now, if Jonathan Tree, he's a geologist with the University of Hawaii, were here, he'd be getting pretty excited about these because they're common and they aren't common, I don't think. And they're just kind of unusual. It's an unusual way for lava to get expressed, I guess.
Hey, Dave. There's
Yeah.
a track there. Do you
Oh.
see anything attached to it?
I'll go look. I'm attracted to it.
Good one. Oh, you know what? I think that's a meandering. That's like part of the rock itself. It's a crack or something.
Zoom in, Roland. Let's
Yeah.
see if there's any cracks in his theory.
I think that one in the center screen coming.
Yeah, that's a. Oh no, wait. Yeah, see, this is probably. Oh, I'm sorry. It is a track, but it's probably where a sea cucumber has been. So if we scroll down a bit, you'll see how there are these big kind of wider sediment patches. That's probably where a sea cucumber has dumped its cleaned sediment after feeding and perhaps moved on or swam away. A lot of the sea cucumbers down here can actually swim, and if we're lucky, we'll get to see one at some point. Okay, cool. Thank you.
One, please.
Coral inside the crevice. It
I
looks like
see
a. See it?
So here's one of these mesh bags that's got a lot of brittle stars on it down there, I think. So
Section
it's just
2 of
going.
it.
And are these just chrysogorgids? Maybe a sea pen, Roland. I think that's what we're looking at. Could take a look at that. I
snap.
don't think we've seen one of these already today. Yes, it is. Chrysogorgid to the right, and a sea pen or penatulation right there in the sediment.
What's that right in the middle? A little more zoom. Is that a shell? What is
Could be some type of a gastropod.
that thing?
Not much, but let's go back to the sea pen if we can get a good look at it. So I think this is, I'm going to put a name on it just so it describes its look. It's something, I think that's called protoptilum, or it's related, that usually have a single elongate stalk, and then they tend to be red, and then they'll have transparent polyps coming off of the main stem. It doesn't have any branches or leaves coming off of it.
I have
So
you at
if
80
it's-
degrees. Pilot.
Even if that name is incorrect, it describes what it looked like. These are all of these names are considered sort of morphotypes. We just try to be as descriptive as possible. But it would not surprise me at all if that is the correct genus for that group. I'm going to check on what
Nav, do
family
you
it
happen
is.
to know
'cause
how
maybe
long
we
ago the ship stopped?
I think it's Protoptilidae.
Copy that.
I'll look that up right now. Yep, it's family
you can put it in
Protoptilidae,
now.
and
Yeah,
I
I
can
think
put it
I
in
can-
as
No, it's good.
Very
Protoptilum.
Don't lose
question
the
mark.
momentum.
Looks like another pirouette victim.
Yep. Candidate, not victim.
When you fly, it's definitely just the candidate.
Just zoom the skids
Bridge,
out of the
right?
way.
Ready
That's
for
good.
another ship move, please.
We have another
30 meters, 040, 0.2 knots.
We have another giant yellow lollipop.
30
And
meters.
I can't believe it. Somebody
040
bid out of this
degrees
one too.
bearing.
That's a
0
joke, of
decimal
course.
2 knots.
Nobody bid out of the sponge. It's
Coming up.
pristine. So I better be careful about joking. But it's got an osculum up on top and this concave face on the other side, and Almost looks like it is an osculum in the back of it too.
The interesting thing is I think it's facing the same way as the other one.
Yeah, they may line up in the current if they're whatever current there is. Now that's got to be 3 of these today. This thing deserves a highlight reel. I mean,
ROV nav.
I don't know if you
moving
can go much farther
Isn't
than
there
that.
like
pilot.
a yellow cartoon sponge that kind of looks like that?
I don't know, a stock yellow cartoon sponge, is there one? We're good for science whenever video's ready.
Video's good. You want to
Yeah.
just go off and I'll
Yeah, we'll let it.
fade off into
We'll
distance.
just let it get away.
You know, as much as I love my sea stars,
God,
I haven't seen
glassy that is.
a sea urchin in a long time. I would like to see a sea urchin.
You know, so would I, actually.
It's been a while.
I'm with you. I like to see all of the different animal groups because it's
Yes.
kind of fun to see how they all figured out how to live down here. Oh, now we got a little uphill in front of us.
This is Bridge. Go ahead.
Hey, I just want to check with you. Where's your bow thruster now, ish?
Going between the starboard quarter and astern.
Okay, copy. Thank you.
And so let's see. I better check the event log here. Is Ken Sulak on? Oh man, I am way behind on the event log. Sorry guys. Let me take a look here.
There's a swimmer in the center. Snap. Oh.
Get awesome footage of this would be good. Never seen it myself.
Maybe an ostracod.
Yeah,
Yes,
so
please.
Ken Sulak.
Oh yeah, it's an
is-
ostracod. Neat. Little
You
bivalve
just
crustacean.
initiated a move, right?
With little swimming appendages.
Yeah, I mean, when that
Bivalve
move finishes,
crustacean,
if there's
is that what
nothing
you
said?
so we can keep
No, I
moving.
know. I don't know him very
Oh
well,
yeah,
but
I'm sorry. Yeah, they're crustaceans, or something similar to it.
I'm always ready.
it's not a pteropod. That's a mollusk. So
Copy that. Yeah,
I think
so
we just
see
got to
something
log this thing
a little
straight in
bit,
the box as
more,
an ostracod.
more to see.
We can move on.
Yeah,
I just wait
Good
for some
video.
tether here.
Okay.
and I was going to say that Ken Sulak has gotten into this discussion about exploration and science and the difference. And he's got in his head, he's got sort of a 4-step process there. The first step in science is the observation or exploration, which we're doing now. The second step is collection of data regarding observed phenomena, and we're doing some of that because we're certainly extracting data
That's,
from the video. It's
Very
not,
nice shot, pilot.
you know, we extract whatever data there is, let's put it that way. The next step is pattern recognition or correlation, and then hypothesis formation regarding the potential cause and effect is the 4th step. So thank you very much, Ken.
We're
That's a pretty
moving
good
in
way to
040,
view the
correct,
whole
Nav?
process that
These
scientists
videos
are
clear.
following. A little bit
Thank
more
you.
detailed and broken out.
Okay, wide, please.
Nice tracking something so small.
It's out there a bit.
You should have tether now, pilot.
Yeah, lots of tether.
See what else we got here. So Scott was also potentially on board with the protoptilum, but he also pointed out that they are hard to differentiate from anthoptilum.
ROV nav,
So
move
thank you,
complete.
Scott. That was that sea
Around
pen we
disc
saw a
on the
little
rock.
while ago. I'm
Bottom.
just getting caught up.
Dave, you see the circular thing just went off bottom?
No, sorry.
Okay, and we're... It's just a
so
dead stump
filter,
or
yep.
something.
And there's the stem right there.
Yeah, we don't really need to image that. I
No.
think there was something upslope a little bit.
Yeah, look like maybe another bolosoma, but
Yeah,
or is it? Yes,
Right.
I recognize that lollipop. Facing the same way.
facing the same way. Interesting thing about these bolosomas, and I hope I've got this right, because sometimes they get mixed up on this, but they're kind of folded inside out. So in other words, this rounded part of the back end of it is actually what would be the morphological equivalent of the inside of a vase sponge. It's called the atrial surface. And then the concave surface, which is actually further inside of the sponge, is actually the external or dermal surface. So these are kind of weird. These are kind of like
This is the
folded
bridge. Go
inside
ahead.
out sponges on a stock.
Move 30 meters, 040, 0.29.
Roger, repeating 30 meters, 040, 0.2.
Trying to get
Coming up.
further along on this ridge, and keep getting deeper as we go up the ridge, which is startling. Yeah, it's just where we are in the ridge, because it can go down and it can go up. We're now at 2540 meters. I think we started out on one of these little mounds or hillocks in the beginning, so we thought we just landed shallower than we actually did, and we just landed on the top and have been going up and down ever since.
So, co-pilot Fernando, I think it's time you came over into the big chair here and got some flight training. Yes.
Sure. Why not?
Yes.
Let me just bring it up a little bit.
ROV nav, move initiated.
So I should ask, actually, how much time you've spent in that chair.
About total, maybe about 2 hours.
Oh, okay, well, good. I should have put you there sooner.
I thought I'd flown with you for longer than 2 hours.
No, I think it's been 2 hours tops. Okay, watch lead. Can you hear me?
This is science. Go ahead.
Okay, so do you guys want to take a look at these sponge right here to the left?
I think that's something we're familiar with already. We can move on.
Okay.
Just take off straight ahead. You're rising a little bit, so ahead and down. I see you in my lower right corner there. That's good heading. Just carry on up the hill.
Okay,
Spiral coral at the top left.
copy that.
I'll point them out. You and science decide whether to look at them or not.
Copy.
Found a starfish just right of lasers.
Oh, okay. So let me just come down a little bit.
Oh, that's an interesting. There's
Gonna
a
be on the bottom
sort of
left.
a many tentacled thing to the left on the side of that rock there. Can we get a look at that, please?
This one right there
To
with
the
the
left?
lasers.
Hard left.
So to the
Oh,
left,
okay.
there's
I see it.
a side of the rock face with a big kind of a sprawling whitish gray thing. Yeah, that rock there.
All right. Partial zoom video.
Oh, little sea anemone.
Tilt down.
Copy.
Oh, maybe even a Ceryanthid. Yeah. Oh, neat. Okay, so this is a sea anemone that I think usually when I see them, they burrow into the sediment.
Max.
Usually they live in tubes. These are what's called Cereanthids, and this group is distinguishable by the second row of feeding arms on the inside of the mouth there. You can see that dark central series of tentacles surrounded by this longer external
Yeah, he's okay.
ring of tentacles.
Yeah, me too.
I'm not sure exactly how it
Yeah,
gets
right.
into the basalt. I think
Okay.
it probably inhabits one of those big cracks in the wall with its tube. So I've never seen one sort of living in a basalt rock before, so that's kind of interesting. Okay, well, once we have video, we can move on.
Just a little lateral left as you lift off.
Okay.
Maintain heading
Thank you.
and push ahead.
Come out video, please. Science, are you interested in these?
We
right
can move up.
here?
Yeah,
We can
you
continue
need to-
moving forward. I think those are just feather stars. We've seen those before.
Yeah, you
Copy.
need to
And
get out ahead.
similarly, the bamboo coral, I think, is something we've seen before as well.
Okay.
Come left a little bit. Carry on into the distance. That's good.
ROV nav, move complete.
Science, let me know if you're interested in anything.
Oh yeah, I know. I'm I'm watching.
Okay.
Um,
Yeah, not a lot to see. I
well,
get it.
partly I'm just trying to scan for things that might pop up. Let's go ahead to that stock structure up in the dark up there in the back.
Okay.
Saw a Ceryanthid in a basalt rock.
Oh,
It's
is that
very
right?
interesting. Yeah.
I'm betting bolosoma.
Are we interested on the one on the left, the one on the right?
Yeah, let's look at the stock structure on the left.
Far into there, it's tubed. There was no way. Because it was like the perfect and one and only opportunity. Tina was on the line too to actually grab one, and it was impossible.
Tilt
I
up.
can only imagine.
Tilting
Yeah,
up.
So
great idea, and that's
yeah.
going to remain a mystery
Oh,
for decades.
It's
I think.
I was just wondering how it got in there in the first
Yeah.
place. So this is a sponge stock. a dead
Bolosoma, I'll bet.
leftover bolosoma, and it's covered by what, hydroids?
Yeah, it looks like
small
it.
little hydra type animals. Which,
Little
and then
tilt
on the other side, there's a sea anemone, a kind of skyphid, something like that.
Didn't
Oh,
see that, but
it
there's
was-
a live sponge and there's a dead one in
Yeah.
front of it. So it shows you that they look like alive and dead.
Yeah, there's a brittle star on top there, probably an Ophiocanthid. And we can move on, but I think if we can catch that sea anemone, just to show that I'm not. That I always
We
saw.
got it good as we approached it.
Oh, you did. Okay. Yeah, then we can move on.
It was a nice shot showing the two together there, alive and dead bolosoma. And then there's probably a little stump
Yeah,
of
I
yet
think
another
so.
earlier bolosoma that's finally gets whittled
Yeah.
down to just a little stump, and then it'll be gone at some point.
Yeah.
Okay, let's try
Completely.
to go for this video.
I don't think they care for it.
Okay.
He's got
So-
some time. It's
Yeah.
good practice.
Yeah.
Partial zoom in.
Yeah, brittle star is good enough.
All right.
Brittle star and a crinoid.
Video's clear.
Okay.
Yeah,
Let's
so
come
that
up.
I can tell you that what I've really got my eyes out for is that giant big hydrozoan cereanthid, whatever it was, that swam away from us the other
I'll
day
show you a trick,
on one of the
Fernando.
first dives. I literally have
Watch
been
my
looking
hand.
every dive trying to see another one
Thumb
of
and
those.
forefinger like
the same
this.
depth?
Tilt like
It
that.
was in the 2000
Oh,
okay.
range-ish, I think.
Yeah. We can move forward, pilot. Thank you.
Copy.
Thank you.
Boy, if we had another shot at one of those, that would be wild. This is, if you go on to the Okeanos online animal
Are
guide,
we fully? Are we
We'll
completely out?
see a
Video.
big, huge animal
Yeah,
that's
sure,
just
full
listed as Cereantheria,
There you go.
question mark, I think. But it's
The bridge,
a
go ahead.
curious animal that we tried to grab and it escaped, and none of us knew that it was going
All
to
right,
take
go
off.
ahead.
30 meters at
That was an
050,
unexpected move, I must admit.
Yeah.
Range 30 meters, bearing 050, speed 0.2.
Good copy.
Thank you. And coming up.
Roger that.
And we've got a sponge coming up, and this is Polyopogon. We've
ROV nav,
seen
moving
the
initiated.
sponge before at least 2 or 3 times and got some good images, so we could probably pass on this one, pilot.
Copy.
He's run out of tether, so he's going to practice on
Go
this
ahead.
while he waits for us to
You
catch
note
up.
it, or shall I note it, Matt? You got it. Okay, thank you.
Oh, he might not. Yeah, right.
Okay, so science, we actually don't have much more tether. So I'm gonna wait for a little bit of tether right here. Let's do a
Okay.
partial zoom video.
Yeah, so this one we call, it's got sort of a flattened top to it. And what letter of do we call this particular species of Polyopogon, because they're undescribed species? And this one we call, let's see, Polyopogon species D. So that's where we're at on a lot of these deep water sponges. In fact, there's probably,
Okay.
there was 40
We're
undescribed
completely
species
out.
a little while ago, and now it's got to be way over
Yeah,
50
sure, full
undescribed just in the Central Pacific alone.
Jeez, I thought I was overestimating when I said 40 the other day.
No, you were not over. You were underestimating. It wouldn't surprise me if there's now 60. I'm going to throw out a prediction.
Another Holothurian.
And this